Alright, so squared, distance across, top function minus bottom function. Top function is 8 minus x squared, bottom function is x squared. So for all of these, what we call a side, what I would call a side, 8 minus x squared, 8 minus 2x squared. Okay? So it's going to be the same on all of these because I picked I picked the same two functions to be consistent. So this is top minus bottom. Always take top minus bottom. That gives you the distance. So for a square, it's pretty straightforward. And I'm going to show you the way to draw these. If you're not good at 3D, if you're okay at 3D, you realize that the squares are coming off like this. Right? There's a whole bunch of squares coming off of here. The base is on here. If you're not good at 3D, and you have a paper in your hands, you can just draw the base and draw a square like this, and then turn your paper like that and look at it. Pretend it's 3D. I'm not joking. Good. Just draw like that and go. You're like, oh, I see. And you at least see. And that way, don't try that in 3D art. They actually want you to draw 3D, right? So,
Here is a drawing, it's like a sculpture and clay. You don't draw 3D objects.
That's good.
okay. I stand corrected. The last art class I took was 8th grade. Remember this? All right. Here we go. It's a shame. I had art teachers that really art. Start and end. Start -2, end to 2 squares. Now, the formula for area of a square is side squared. So this is pretty much the easiest one. The very end of the Play-Doh manipulation lab, we said we need to add up all the slices. So if you find the area of one slice, this is the only thing that's going to change in all of our integrals today, is that slice. And if you want to think about it this way, this is the area, if it's a rectangular prism, and this is the area of the top, so it's really a square prism, and this is the width, dx, super small width. So you'd be very accurate if you cut out squares of paper and glued them all together. It's the worst detention project ever. Make this thing out of paper. And you have all this, you glue all these slices. You guys know what phyllo dough is? What we could do with that? Make a 3D shape out of phyllo dough. Okay. Katie smirks. What's smirking about, Katie? My 3D art knowledge? Still funny, isn't it? Yes. All right, so let's go to the next one. Okay? Equilateral triangle. And you don't have to rewrite on the top. You have another spot right below it. Yeah. Our side is still 8 minus 2x squared. That is the bottom of the equilateral triangle. So a tricky 3D way to draw it is right here. I would look at the equilateral triangle this way. So here's how you can think about this. This is a side. Area of triangle is base times height. There is a shortcut for area of an equilateral triangle. There's a formula. You knew it at one point. You probably forgot it. It's like anything else memorized. Here's where it comes from. Ready for some fast trade? Right here, this is half of the side. Whatever side is, right? This is half side. That means that this is half side radical 3. Area of a triangle is 1/2 base times height. You will remember once we multiply all this out, you will recognize the formula. I don't know if you remember it. Side squared radical 3 over 4. I like to make the S like that. This is the one I would probably think about memorizing. It shows up, and you don't have to go back and reinvent that formula. It's the area of the equilateral triangle. I don't know why they don't give you that formula, but sometimes they will give you a formula if it's an unusual shape. Okay, so the only thing that changes in our integral is what we're putting there. So negative 2 to 2, side squared. I put the radical 3 over 4 out here. So all you got to do is find the side on all of these. Anytime it's a cross section, find the distance between the distance across, and you can do these problems. That's the hard thing. Maybe, man. That's unusual. No. Okay, let's go to the next one. Not making any more art terminology errors. This goes on the internet. I'm busting. Check. Isosceles triangle, leg on base. Okay, here's our base. Isosceles, and it should say isosceles right triangle, because it's always going to be right triangle. Leg on the base looks like that. Also known as a 45-45-90 triangle. Okay, those should say isosceles right triangle. Well, formula for area of a triangle, if you turn it this way, area of a triangle, 1/2 base times height. The base is our side, and the height is our side, because the leg is on the base. So the formula for this, for one slice, which we want to find slices, the formula for one slice, negative 2 to 2, 1/2 side squared. And our side, we said, was 8 minus 2x squared. Squared. So you might notice this, because you guys don't know, that means it's half of a square. Well, what is a 45-45-90 triangle? It's half square. And all of your math up to this point is all going to be coming together in a giant connection. Okay? Isosceles triangle, leg is on the base. That is important on what is on the base, because the next one is isosceles right triangle with hypotenuse on the base. And by the way, this one, before we go to that next one, this one I think is a good one to draw. You're making all these shapes going this way. You make them all the same, pretty soon you see what the shape would be. You can pretend that you can draw 3D, but not sculpture. It is fun. Alright, so isosceles triangle, hypotenuse on base. Ooh. Let's go like this again. This time we have hypotenuse on the base. Let's do a little thinking. This is the side. Area of a triangle, 1/2 the side times the height. So we need to figure out what the height of this puppy is in terms of side. Well, look. makes another isosceles triangle. Isosceles triangle right here. All those proofs you did, the altitude to the hypotenuse of an isosceles right triangle is also perpendicular bisector of the hypotenuse. You can see by looking. Yeah. Duh. That's symmetric. When I cut it in half, it's still symmetric, dude. Thanks for the proof. Geometry is about the only place you ever use those proofs, by the way. I said that kind of twice. The microphone doesn't pick it up. I don't want people knowing that. So what is this distance right here? Half side. So this is half side. So the area of our triangle, side times half side. What's that half from? For a triangle. So 1/2 base times height. So that's formula for triangle hypotenuse on base. I don't know, maybe you want to memorize that one too. I think that one's easier to come up with than the equal half triangle one. So if you're writing your integral, -2 to 2, 1/4, 8 minus 2x squared dx. And you might be saying to yourself, it looks like that's 1/4 of a square. The triangle is smaller if the hypotenuse is on the base than if the leg is on the base. Because if the leg is on the base, then the other leg is the same height, which means hypotenuse is bigger. That's why it's half the size. What?
Can you re-explain the part where it says 1/2 side height and then it catches up?
What's formula for every triangle?
1/2 base times height.
Okay? That's where I started. Okay? So 1/2 base times height. And then I took out height. The height is half of this side. So that's where the 1/4 is kind of smeared together here. So there's your 1/2 base times height. Yeah. Get all that stuff come up, and I was kind of fast. Let's get to some easy ones. Those triangles. Circles are a lot more fun. You know the formula for every circle, Owen?
Yeah.
What? Pi r squared. That's all you need for this next one. Here we go. Let's check it out. Go ahead and make the drawings for your picture first, and then we'll do the formula. So we did this, I think we did semicircles with our Play-Doh, right?
Yeah.
Again, my little tricky method for you is just do this on your paper. It works way better on the document camera if I can show you here. But you do that and then turn your paper, it will appear that those shapes are going that way. You don't have to go make this drawing. I think it helps that you know that the tallest part is in the middle because that's where the longest base is. Does it work actually turn sideways? A little bit. Just a little bit.
Right.
Yes, it does.
Dollars for much.
You look at it like that? Oh.
So weird.
Oh. Alright, let's pretend. Area of circle, Owen said, was pi r squared. This is a half a circle. You just got to make sure that we know the radius. Well, the radius, is the radius the whole side? No, radius is half the side. Radius is a half side. So area of one slice is a half pi r squared. This is a half circle. But r is a half side. So a half of a half side squared. Dude. So our formula for semicircles, this is 1/4 times a half is an eighth. It's really pi over 8 side squared. This is going to be interesting because when we do quarter circles, they're going to have a bigger area than semicircles. Some of you struggled with I didn't take any pictures of your semicircle ones or your quarter circle ones, but those were fun. Because you kept trying to connect them with other quarter circles. But really, the quarter circle ones should blow up off the page because the radius is all the way across. Okay. So this was pi over 8. I don't think to me, this is a waste to memorize this one. When all you have to do is go, okay, it's a half of a circle, which is pi r squared. The radius is all the way, or the radius is half the side. You can come up with that formula. Triangle one, no. That one meter thing now is just going to make it sleepy in here. Quarter circles. Erase your picture. Erase my picture. You have another picture. Quarter circle. That means they're popping off this way. Actually, going to hold the paper sideways. These are bigger because the radius is all the way across. The radius is a side. So the area of a quarter circle is a 4th pi r squared. That's just in general. That's not calculus. 1/4 pi r squared is a quarter circle. But our radius is the side. So 1/4 pi side squared. So this is a semicircle, is pi over 8, and the quarter circle is actually pi over 4. It's twice as big. That's wonderful. You can go home and tell your parents. Actually, when we're doing the volume of cross sections, Mom and or Dad, Uncle John, a quarter circle is twice as big, volume-wise, as a half circle. What do you think about that?
Nobody cares. No, my dad was just smart. Like, at least you're finally losing something.
That makes them mad, and they want to slap you around and give you chores to do. Okay, rectangles. I did not explain rectangles because the area of a rectangle is the base times the height. They're going to tell you something like the base is on the figure and the height is twice as big as the base. So you would take base, or the side, times 2 times the side. Okay, I didn't go over rectangles. That's it, cross sections. The only other part of cross section is what to do. Sometimes they'll say the cross section follows the function y equals 2 sine x plus 3. So that means the top of the solid is wavy. You won't have to draw it, but you guys find the volume. The volume of anything is the integral of the slices. You add up all the slices, you got it. Alright? Figure that's on here,